This is a continuation of our notes from 6.3 on dividing polynomials. Today we're going to take a break from longhand division and we're going to discuss synthetic division. So synthetic division is a shortcut. It is a pattern that we use to help us avoid all the variables. So synthetic division is a shorthand method of dividing polynomial by a linear binomial by using only the coefficients. So we're going to cut out the variables. Now what you need to remember is the divisor must be of the form x minus a. Notice it's x minus a. Okay, so we have to watch for that. A is what we're going to use to help us divide. Okay, A is what we're using to help us divide. Now, just like in longhand division, we need to have our dividend in standard form, and we want to look for any missing powers. So we would fill that in with the 0x or 0x squared. Then we want to always show what we're dividing by, which is x minus 3, which is of the form x minus a. The other thing you need to remember is the coefficient on x has to be 1 in order to use synthetic division. Otherwise, you'll need to divide out. All right, so when we go to do this, I can see that I am missing an x squared. So I'm going to put in a placeholder of 0x squared. So when I set up synthetic division, I am taking the coefficients. So I am going to put in here a 1 in place of the x to the fourth. A negative 2 is the coefficient of my x to the third. So here's my fourth power, my third power. I am missing the x squared, and then I have a positive 3 and a positive 1. So we pull the coefficients, a 1, a negative 2. My missing power has a coefficient of 0, a 3, and the constant 1. Now, I am dividing by a, which in this case is 3. It's not negative 3, remember, it's x minus a, so we use the value of a. If it was x plus 3, we'd be using a negative 3 here. Now, to set up your synthetic division, we're going to go ahead and draw a line. And then it drops down the first term, so we put a 1 here, okay? And once we put that 1 there, the next thing that we do is we take our 3, we put a 1 here, and then we take our 3 times 1, and it comes up here as a 3. We find by adding these, just like before, negative 2 plus 3 is 1, and then we go again, and we take our next term, and we multiply. And we take our 3 times 1, and we get a 3 here again. Okay, so we're coming back. I'm trying to find a way to write this line here. 3 times 1, we come back up. Now we add these together, and we get 3. And we go again. We take 3 times 3, and this time we get a positive 9. We add these down, we get 12. We go again, and we take 3 times 12. So again, the 3 times 12, we get 36. We add these down, and this last number, that is my remainder. Okay, so what I've done is I've divided out that first power, and so every number down here is 1 less than we started with for our power. So we would have 1x to the third plus 1x squared plus 3x plus 12 plus a remainder of 37 over our original divisor, which was x minus 3. So there is a pattern that we are following to do this. So let's look at another example. We're going to start by seeing if we need any placeholders, and I don't need any placeholders, no placeholders here. So we are going to pool the coefficients. So we have a 1, a negative 3, and a negative 18. So again, we look at this, we want to make sure it's in standard form. We pull the coefficients. That's what makes it shorthand, is that we're not using all the variables. So we have 1x squared, a negative 3x, and negative 18. So we pull the coefficients. We are dividing by x minus 6, and that is in the form of x minus a. So our divisor is just the 6. We put that out here to show that this is our divisor. Draw a line coming down, and the first thing you do is drop your first term to start. Then you take your 6 times 1. So again, you're going to take this times your remainder, or your leftover. 6 times 1 is 6, and you add down. We've already accounted for that negative. Negative 3 plus 6 is 3, and then we start again. Take negative 6 times 3, and we get 18. And when I add down, I get a remainder of 0. That means there is no remainder. And since there's no remainder, that means that x minus 6 is a binomial factor of my quadratic trinomial. How do I write my final answer? Well, we pulled the x squared, and so now we're down to 1x to the first plus 3 with the remainder of 0. All right, so another example. This time we have a fraction, and that's okay. We need to set it up. We want to make sure it's in standard form. So the coefficients we pull are 4, negative 12, and 9. We do not need any placeholders. Now, if you look, I have x plus 1/2. That means my divisor is negative 1/2. The form is x minus a. So if I'm looking at this and it was x minus negative 1/2, that gives me my plus sign. So again, my divisor is negative 1/2. A is negative 1/2. And when I go to do this, I do the same thing. I bring down the first term, which is 4, and then I start by taking negative 1/2 times 4. That gives me a negative 2. I then add down, I get a negative 14. I start again, I take negative 1/2 times negative 14, and that gives me a positive 7. I add down, I get 16. This last piece is my remainder, and I refill in my coefficients with the proper variable. So I would have a 4x minus 14 plus a remainder of 16 over x plus 1/2. Now, as we get into later chapters, we're going to learn that you're not allowed to leave a fraction in a fraction. At this point, we are leaving this, but later in the year, we'll be addressing issues with fractions in denominators.